Hello friend, my name is Derek Harder, and in this video we're going to continue talking about application program development, and we're going to be looking at some of the details about how a program actually works on a digital computer. Alright, so let's go ahead and begin. So a computer CPU can only understand instructions that are written in machine language. And machine language is literally bits, a sequence of bits, a sequence of numbers, right? So people find it very difficult to write, impossible to write programs in machine language. So other programming languages have been invented, so-called higher level languages that can be translated or compiled into machine language that the machine actually understands and can run. So a central processing unit in a digital computer is designed to perform very simple operations on pieces of data. So it's good to keep in mind that these operations, the instructions of a CPU are very simple. They're things like reading a piece of data from main memory, doing some arithmetic like adding two numbers together, doing things like moving data from one memory location to another, maybe comparing two pieces of data to see if they're equal or not equal. Very simple kind of atomic operations, right? So the instructions are simple, but the power, it's good to understand that the power of a digital computer comes because it can do literally billions of these very small things a second, right? So the speed with which it can do really simple things combines to make for impressive programs, right? To be able to solve impressive problems and do really neat kinds of applications, okay? So some things to understand that we're going to be talking about in this video. The programs must be copied from secondary memory to RAM. Okay, so RAM is not long-term storage. So when we create a program, when we write a program file, we're going to save it in a file, which is going to be on secondary storage, so that's a hard drive. But to actually execute a program, we have to actually load it into primary memory. Okay? So what the CPU is doing at the fundamental level is it's just fetching, decoding, and execute. So it fetches one instruction, decodes it, to figure out what that instruction is, and then it executes it. And then it fetches the next one. So it just continually fetch, decodes, executes in order to run a computer program in machine language. Okay, so here's a figure of what I was just discussing there, right? So think of this as a loop that happens forever, and it happens very fast, billions of times per second. Fetch the next instruction, decode it, execute it, we're done with that instruction, get the next one, and keep going. Right? So as we already mentioned, it's impractical for people to actually write in machine language. Okay, so there is a level that's not a high-level language called assembly language, which uses mnemonics for instruction. So really, there's a one-to-one mapping between an instruction in the machine architecture, in the CPU architecture, and these mnemonics. Okay, so we're not going to write an assembler in this code, but here's an example of like some x86 assembly code. So there's some these correspond to some of those basic instructions I was talking about, like moving data from one location in memory to another, making a system call, doing this is like an arithmetic, this is an XOR instruction, and so on. So an assembly language would really be considered a low-level language, okay? So high-level languages are things like C, Python, Rust, Go, things like that you may have heard of, okay? C, C++. I mean, most textbooks you look at will only divide this into low versus high level languages. So some people talk about system level languages. You can kind of think of these as kind of a lot lower than a typical high level language like Python. So usually system level languages are still typically compiled languages, and these are often used to build system programs, like we talked about in the previous video, right? So because when you need high performance, you still need something that's relatively close to the machine architecture, right? So C and Rust and things are going to be like these system level. But in this course, we're going to be looking at high-level languages. So C++, Python, other languages like that would be considered high-level languages, right? So these provide a simplified interface for the programmer. They hide a lot of the complexity of the actual, computer architecture. They're more intuitive to understand and easier to program and build applications with much faster and much more easily. So any high-level language like Python is made up usually of these kinds of four components. So there's basic keywords that are predefined words that are used in the programming language. So each language has its own set of keywords. So these are the full set. I believe this is the full set of the Python keywords over here. Operators. So there's a definition of operators that perform operations on data. Okay, so we'll talk about different kinds of operators, but you're probably already familiar with math operators. So like plus, minus for addition, subtraction, multiplication. Those are what we mean by operators. And then there's a syntax. So there's a set of rules to be followed when you write the program so that we can either compile it or interpret it into machine language. Right? And then there's statements. So the syntax defines how you specify a statement, which is you can think of as an individual high-level instruction. So usually one statement in a high-level language gets compiled or translated into multiple machine-level instructions. So, a digital computer does not understand anything except for a machine language program. So in order to actually use a high-level language, programs written in those high-level languages have to be translated into the machine language in order to be executed, okay? So there's two primary ways to do that. We can either compile the high-level language into the machine language, or we can use an interpreter, okay? So Python is an interpreted language, and we'll say what we mean by these, okay? So those system-level programs I talked about tend to be compiled, so you usually can get higher performance in a compiled language. Not all the time, but it's tougher to make applications that really need high performance in translated languages. Okay? So the thing that we translate from the high-level language to low-level is called the source code. Okay, so you're going to be writing source code to create small applications in this class, right? And if you have something, if I can go back to the previous slide, if you have something that violates the syntax, it's not an allowed way to write a statement, this will cause a syntax error. This will prevent your code from being interpreted or compiled. So it'll prevent it from being translated successfully down into the machine language in order to actually be executed. So in this class, we're going to be using Python, which is an interpreted language, but you should know the difference between a compiled language and an interpreted language. So a compiled language has what's called a compiler. So it does the translation from the high-level language into a actual machine language binary executable, okay? So typically this compiles down and gets saved into a file, but this file is actual machine language. It's an actual sequence of bits that at any time we can load that from the file into main memory, and those will be the machine instructions that the CPU can fetch, decode, and execute to actually run the program. Okay, so compiled languages are a two-step process: compilation into the executable, and then at any time we can execute. We can load that executable and have it start running on the computing system. But in this class, we're going to be using Python, a high-level language that's an interpreted language. So basically, the interpreter is actually compiled. So it's actually an executable, but what the interpreter does is it reads, this is oversimplifying a bit, but it reads one Python statement at a time, interprets it, so translates that down into machine language instruction, and then has the CPU execute that instruction, right? So the interpreter is basically doing the fetch and the decode into a machine language instruction before it sends it over to the CPU, that machine instruction to be executed. And one thing I'm skipping over, I already mentioned those, that usually these Python statements get translated into many machine instructions, right? So one statement is not going to usually translate to a single machine instruction. One statement is going to be a large number. One Python statement is going to be a large number of machine instructions when we interpret it. Okay, so in summary, in this video and in this part of the chapter, you should have learned that a CPU only understands machine instructions. This is really just a sequence of binary numbers. A CPU runs machine instructions by fetching, decoding, and executing the instructions one at a time. It does this very, very, very fast, billions of times per second. Machine languages are impractical for people to write directly, so we can kind of indirectly write machine language by using an assembler, which has mnemonics that correspond one-to-one to the instructions in the machine language architecture. Okay? But most applications, still assembly is too hard usually to write a complex application, so most applications will be written in a high-level language for speed and simplicity. Okay? So a high-level language, you should understand, is made of keywords and operators. There's a defined syntax. So every high-level language defines a syntax which tells you how to create a statement in that high-level language. And so in order for it to actually run a high-level language, it has to be translated into machine language. So there's two ways to do that. Either it's a compiled language where there's a compiler that translates that into an executable file one time, and that executable file can be executed as many times as you need. Or the language is interpreted like our Python languages that we're going to be using in this class, where really the interpreter is actually a compiled program. But what the interpreter does is it's kind of doing a fetch decode. So it's fetching statements in the high-level language, a Python statement. It decodes those into and translates those into the machine language instructions, and then sends those over to CPU one by one to be executed. Okay, so all right, so that's it for this video. I hope you find these useful, and I hope to see you in the next video or in class.